So, first day of geometry. What we're going to start with is defining a bunch of items, okay? And the first three items, these are the building blocks of geometry. Everything we do in here for the rest of the year comes from these three things. Now, they're called undefined terms, not because we don't know what they are, but because mathematicians across the world throughout the centuries could never agree on one all-encompassing definition for what it is. Okay? So, because different cultures and different continents and countries would come up with a slightly different definition, we all agree what it is in our heads. Philosophically, we all agree what it is, but we couldn't put it on paper, apparently. So, apparently they just gave up and now they call them undefined. All right? So, the first undefined term in those 3 points, or those three definitions that are the building blocks of geometry, are point, line, and plane. Okay? Point, line, and plane. So a point, the fundamental building block of geometry, one of our three building blocks in undefined terms, it's just a location. A point is simply a location. It has no size, so it has no width. It is simply a location. So you might think to yourself, well, I'm going to draw a point like, like that, like we did in Algebra 1, right? You guys took an X and a Y axis and you plotted a point on it. That dot is really not a point. It's a representation of a point. Because the point, that location, is actually much, 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 much smaller. It has no size. It's a location only. Okay? We represent points. Obviously, we can't draw something that has no size. We have to use pens and pencils and things of that nature. So we have to use a dot to represent a point. And we're going to label that dot with a capital letter. That is an important thing you need to know about the items we have here, okay? Points are always labeled with capital letters. So, for example, we could call this point A. You can see the point there, and we have a capital letter A written next to it. Okay? Now, if we're talking about point A, you don't have to always put the word point out in front. Okay? Excuse me. In the context of what we're writing, you're going to know it's a point. Okay? So you don't need to actually write point A. We would just write it A. Okay? And that's a period, by the way. That's not a point for the thing. That's just ending the sentence. So you just say A. I'm talking about point A. Next is a line. Now, a line is a collection of points. Okay? It's a collection of points in a straight path. They say a line is represented by a straight path that extends in two opposite directions without end and has no thickness. Now, it has no thickness because points have no size, right? So points have no size. So we are thinking about a collection of points going in a straight path forever. Now, if I was able to take that, so we can talk about length. Right? We can now talk about length. But if I were to turn that and look right down, I wouldn't see anything. Because there's no thickness to it. It's not like a wire that has a gauge thickness to it. Okay? It has no size. It only has length. Something else about lines. Lines are not like the lines you drew in when you were little kids on sidewalk. Sidewalk chalk. Okay? Those are not lines. Or at least those are not lines in the geometry sense of what a line is. Okay? Lines are always straight. They go on forever in two directions. Okay? Forward and backward. All right? And the way we represent those, we need to know, and you saw this in Algebra 1, to draw a line, you needed at least 2 points, right? In fact, when you guys actually graphed lines, you would go, okay, where's the y-intercept? You'd graph that point. Then you'd count a slope and find another point. Then you draw a line between those 2 points. Right? Remember doing that process? You needed 2 points to draw the line. Same thing here. To be a line, it has to have at least 2 points on it. And then we're going to name it according to 2 points that are on that line. It can be any 2 points on that line. So if we have a line that has 15 points on it, just pick 2 of them. That's the name of the line. Okay? And when we do that, we use a symbol to tell everybody we're talking about a line. See the little symbol at the top there above the A and the B? It looks like a line. It's a bar with 2 arrowheads. Easy peasy. Okay. There is another way, and later on in this class, we might change how we talk about lines. It's kind of the idea if we want to talk about the forest instead of the trees. Okay? If I want to talk about the forest instead of the trees, I may not say line AB. I might just call it line L. And there's a little L sitting up here with no point by it. It's not a capital letter, so I know it's not talking about a point. It's talking about the entire line. Okay? So sometimes, and this will be later on in class, we might want to talk about line 1 and line 2 and line 3, or line L, line P, and line Q. Okay? But that's going to be later on. We're talking about the whole lines, not the individual points on them, not the parts that make it up. All right, with me so far? All right, make sure you stop me if you have questions or anything clarified. Next is a plane. The plane is the third and last undefined term. A plane is a flat surface. Okay, now they have it drawn here in the diagram, kind of that parallelogram, just because else do you, if you draw it just being in the paper, then it looks like just a square. And I was like, whoa, so all planes are squares. Well, planes aren't any shape. Planes, again, go on forever in all directions. Think of a piece of glass that has no thickness. Okay? There's no thickness. Why is there no thickness? What's it made up of? Points. Do points have size? No. So there's no thickness to it. Okay? But now we can talk about length. Now we can talk about width. Okay? And it goes on forever. Forever. In our 2 directions, obviously left and right, up and down. That's why we call it 2-dimensional shapes, because they can fit on a plane. You can draw them on a piece of paper being a good representation of a plane. Okay? Now, to talk about planes, to name planes, you need 3 points, a minimum of 3 points to name a plane. And they can't just be any 3 points. Okay, there's a vocab word, and I'll show you, it's at the top of the next column on your notes here. But the vocab word is collinear. Okay, who are your co-workers? People who you work with, right? People who have the same job as you. What does linear mean? First 4 letters in linear is line. Oh, it means a line. Okay, so collinear are points that are on the same line. Right? Pretty easy to know. And so we cannot use collinear points to name a plane. And this is why. So if you think of my tablet here, and those of you watching the video, I apologize you can't see this, but if you think of my tablet here, and think of that as a plane, so obviously it has thickness here, but let's assume it didn't. It was totally flat, no thickness. If I pick just 1 point and try to name my plane according to that point, this plane is not the only plane that goes through that point. There are an infinite number of other planes that can go through that point, because this plane is different than this plane, different than that plane. Okay? If I pick 2 points, well, now I can't wiggle it left and right, but I can still wiggle it front and back. So I still have an infinite number of planes that go through those 2 points. I need 3 points. Think of it like a tripod or a stool with 3 legs. I need a minimum of 3 points to have a nice, solid, this is the only plane I'm talking about. Okay, you get the idea? All right, now what if those 3 points were on the same line? I got one finger longer than the other. There you go. What if those 3 points are on the same line? Well, now it still wobbles, right? So our 3 points cannot be on the same line. They cannot be collinear. Think of that tripod. They have to be on different lines so that we can talk about one specific plane. Okay? All right. So to name planes, we would name them according to 3 points, 3 non-collinear points. For example, this plane, we could call it plane ABC. And you can look at the diagram and see that we have those 3 points, A, B, and C. They're not in the same line. I know they're points for 2 reasons. It's obvious. Why do I know they're points? Capital letter, and there's a dot next to it. Absolutely. That's how I know they're points. Okay? Capital letter and there's a dot next to it. Okay, so I know those are 3 points. P. P is not a point. P is those shorthand representations, shorthand name for the entire plane. Okay, just like I said, sometimes we'll use line L to represent a whole line rather than talking about the points. Same thing with planes. We could, in some cases, call this plane P. Now again, this is kind of a typo from the book. When they're naming a whole plane, they won't use capital letters. They'll use lowercase letters. Okay? Because only points get named with those capital letters. So it'll be plane P or plane. They like to use M and N and L a lot. But they should be represented as lowercase letters, not as points. All right, so there's our three foundations of our three foundation definitions for geometry. Any questions? Anything about those change from what you originally thought they were going to be? Like I said, a lot of these you guys have probably already heard of, and I'm just trying to clarify for this class. Good to go? All right. Well, let's try something here real quick. Off to the side, we got, first off, we have two more definitions. Which, by the way, if I have a definition for you guys, I'll have it typed up for you. If I have a rule for this class, I'll have it typed up for you. So one thing you might want to grab at some point is a highlighter. Okay? Because just because I have it typed up doesn't mean you don't have to read it at some point. And you might want to highlight, you might want to add your own little note to make it clarify for you, because something that goes on your head to help you remember that might be something you want to write down. Okay? So just please be following along. Just because I have it typed up for you does not mean you get to sit there and sleep. You need to follow along and actively participate in these notes. All right, so we already talked about collinear. That means they're on the same line. So then what do you suppose coplanar means? Same plane. That's exactly it. They're on the same plane. So looking at our diagram here, the first thing we need to do is we need to train our eyes to look at this diagram properly. Okay? That's going to be a big part in this class, is making sure that you actually know what you're looking at. Because in our class, one definition I didn't go over, which is a fairly simple one, but space. Space is all points in all three dimensions. Okay? Space is all points in the universe. It's all three dimensions. Okay? That's what space refers to. So if we are up here and we are drawing a diagram that is in space, again, space now has a new connotation in this class, right? We're not talking about outer space, okay? So we have a diagram here that's drawn in space, 3 dimensions, but we have a 2-dimensional piece of paper. So they have to give us some visual cues to help us look at what we're seeing here, okay? Help us understand what's on the paper. So looking at this, a couple things. First off, this plane is drawn kind of slanted. It's kind of drawn like a parallelogram. Okay? The cue that they're trying to give you is that you're not looking at it like this. You're not looking at it like this. You're looking at it kind of like this. It's kind of slanted. Okay? That's how you're looking at that plane. It's kind of slanted at you as far as your point of view. All right? So then why do you suppose these dashed lines are there? Why is that there? What's the point of that? What it's trying to tell you is that if this was a real thing that you're looking at here floating in the room, that dashed line, or those dashes, are part of the line that you actually can't see. They're hidden from view. Okay? So what this actually is, if my iPad is the plane, then my pen coming straight out of it is the line that we're looking at, that line going up and down here. That's actually coming out like this. It passes through the plane and out the bottom. So, you see the little nubbin at the top of my stylus? Yeah. If I hold this like this and I put this there, can you see it? Because it's hidden from view. So I draw it as a dotted line. Catch the idea? But you can see the bottom of my stylus. That's why all of a sudden they go back to a solid line, because you can see it again. Okay? That's what it's there for. So you kind of see what you're looking at now? So you're looking at a plane at an angle and a line going straight through it like that. Okay? Great. All right. So we want to look for, what is QT? What does that symbol mean there? Line. It's a line. We want to find another name for line QT. Please write down 2 other names. All right, well, if you're trying to find other names for that line, you might need to know what are other points on that line. Well, obviously Q and T are points on that line. What else? Ooh, R is not on that same line. This is the line we're looking at right there, this guy. Okay, N is on that line. Okay, absolutely, N's on that line. M is M a point? How do you know? Lowercase. It's lowercase. It's not a point. N is the point. M is not. Okay, so another way to name this line, you could say that we're talking about QN. Make sure you use the proper symbol. It's a bar with two arrowheads. That has to be there or it's wrong. Okay? I'm not going to play the mind reader game. I'm not going to say, well, you guys knew what I was talking about because it says to name lines. No. If you don't name it properly, it's wrong. Okay? Let's see. How about another one? TN. Sure. Line TN. You know what you could have done? For these three names we now have for this line, you could have just moved the letters around. Right? Rather than line QT, how about line TQ? How about line NQ? How about line NT? Same line, now a different name. Okay? And there is one more name that we could give this. Exactly. But now we can't just say M. We have to actually write out the word line M. Okay? Awesome. Because yeah, M is now talking about that whole line. Good. Let's see, what are two other ways of naming plane P? Well, again, we need 3 points, right? Can those 3 points be on the same line? No. So, quick question, what can we not name plane P? What can we not name plane P?
RQS.
We cannot say plane RQS. Okay, because that does not define one specific plane, because that plane could still wobble, right? So, what point do we have to have in our name? Chris?
V.
Got to have V. Right? V has to be in the name because V is the only point that's on that plane that's not on the same line. See what I'm saying? So we could say that this is plane VRS. Okay, plane VRS. That is a perfect name for that plane. What's another one? Plane. Is T on the plane?
No.
Remember, that line's going straight through like that, so T's like up here hovering above the plane.
Plane QS?
VQS. You have to have V in there. You have to have 3 points. So if we have plane VQS, that would work. Okay? Yes, you could have, you could just change around the letters, obviously. You could say VSR. You could say plane VQR. Okay? But V has to be in the name because V is the only point that's not on that line. Okay? They have to be 3 non-collinear points. Okay? All right, so let's see here. What are then, we already answered this, but what are the 3 collinear points? R. Make sure you put a comma between because we're talking about it, we're making a list here. R, Q, and S. Those are our 3 collinear points. Well, what are the 4 coplanar points? 4 points that are on the same plane. Go ahead. V, it's the same list as our collinear ones, except now we add V to it, right? V, R, Q, and S. So now we have 3 more definitions to talk about, and then I will be quiet. So, now that we know what points, lines, and planes are, we agree what they are, we can name them. Now we want to talk about some defined terms. Remember, point, line, and plane, those are our only 3 undefined terms. So now we have defined terms, things we can actually talk about with definitive definitions. So the first one is a segment, or a line segment. Okay? A line segment is a part of a line that consists of 2 endpoints and then all the points between them. Okay? 2 endpoints and then all the points between them. So for example, you're looking at the diagram. if I had line AB like we had at the top of the page, with the definition of line, if I only took point A and point B and then everything between them, that's now a line segment. Okay, and we name line segments according to their endpoints, and the symbol is simply a bar. Okay, just put a bar across top, no arrowheads. That signifies you're talking about a line segment. Okay, you could also switch the labels there. Line segment AB is the same thing as line segment BA. Okay? All right, next, we could talk about a ray. Now, think of a ray of sunlight. Where does the ray of sunlight start? At the sun. So therefore, the sun would be its endpoint. Endpoints does not mean where something stops necessarily. It could also be considered where something starts. Okay, but we still just call it an endpoint. All right? So a ray starts at an endpoint, and then it goes on forever, just like sunlight, goes on forever in one direction. Okay? So the way we name rays is we always name it starting with the endpoint. Okay? So here in this example, we have ray AB. So A is the endpoint. It's passing through B. So B is another point it's passing through. And then the symbol is just a bar with one arrowhead. And by the way, that arrowhead always points to the right. It doesn't matter what direction the actual ray is going in. When the label for it, when we write it, it's always pointing to the right. The first letter is always the end point. The second letter is a point it passes through. And the symbol always points to the right. Opposite rays, if you were to look at a diagram, such as this diagram here, it looks like a line, right? It's a line with 3 points on it. Well, we can take this line and talk about it as two separate rays. Okay? We can talk about it as ray CA, which is the ray that starts at C and passes through A. And we can talk about it as ray CB, which is the ray that starts at C and passes through B. Together, they make that whole line, right? Individually, we call them opposite rays. Opposite rays have the exact same endpoint, but go in opposite directions. Okay? Please remember that they have to then form a line. They form a line. It's not that one goes this way and one goes that way. That's not forming a line. By the way, a little pre-test, what is that forming? Well, you're using that word for what? It's an angle. It's forming an angle. And no, that's not a cube. But that's beside the point. It is kind of cute, but no, never mind. Okay, so we're good to go opposite rays. They form a line, yes? Great. Let's take a look here. Naming segments and rays. What are the names of the segments in the figure? Did they say how many to name? Did they say name one or name two? We want all of them. Your homework will say the same thing. If they say name the rays, they mean name all the rays. If they say name the segments, they mean name all the segments, okay? So looking at that diagram, what segments do we have?
Segment DE.
Segment DE. And to write that, I use capital letters and I put a bar across the top. That is the only way that's acceptable. Now, could I give that segment a different name?
Yes.
I could switch the letters around. For segments, it's okay to do that. For rays, it's not. For rays, there's only one way to name a ray. Well, one endpoint for a ray, right? That first letter has to be the same. How about another segment?
Segment DF.
Segment DF, that would work. And again, bar across the top. Could I change those letters around? Yes, I could. Segment FD is still the exact same line segment. And what else? EF. And again, yes, I can switch those around. Ray FE is fine. It's the same, or I'm sorry, segment. I keep saying ray. Sorry, segment EF and FE are the same segments. Questions? How about naming rays? Anyone?
D.
Ray ED. So if you're talking about ray ED, that's how we write it. And you are hopefully talking about this ray. Yes? Starts at E, passes through D. Can I switch that around? Can I say I'm talking about ray DE?
No.
Okay, now wait a minute. Is it the same blue ray? No, not the same ray. But is there a ray DE? Yes. There is a ray D. I'll even put that one in red. DE is a different ray. It starts at D and passes through E. Okay, you with me, guys? All right, so let's name a few more. Ray, I heard you say one. Ray FE, that's a good one. Starts at F, passes through E. By the way, is there another name for ray FE? I can't switch them around. It has to have the same endpoint, so it has to start at F. Ray F, let me make that one in black so you can see which one I'm talking about. Ray FE could also be named ray FD. They're the same ray because they start at the same endpoint and they're going in the same direction. Got it? All right. I could also say I don't have EF up here yet. There is a ray. Let me erase some of my markings. Oop, that's not the eraser. There we go. Let me erase some of my markings up here. We have another ray EF that we haven't discussed yet. And that is the ray that, again, starts at E and goes through F.
What about FD?
FD. FD is the same thing as FE.
I mean DF.
DF is the same thing as DE.
Oh,
Yep.
shoot.
Yep. No, you're okay. That's just, they're the same rays. They're technically already listed there. Okay. So let's see. Oh, that's what I was going to say. You might be thinking to yourself, well, how do I name this ray? How do I name the ray that starts at D and goes out that way? The answer is we don't. Because theoretically, philosophically, we don't actually know that there's any points out there. Because they're not labeled for us. We can't see them. Right? So we've got to go with the things that concretely we know. Now, intuitively, you're like, well, wait a minute, it's a line. And so it has to keep going to points, right? But we don't know their names, so we can't name them. We can't use it. Okay, we just can't use it. All right? Okay, which rays are opposite rays then? Okay, so make sure, don't list it this way, please. And you would never have done this, I'm sure. But don't just say ED and EF.
No, you gotta put the...
You actually have to use the symbols. All right? It is ray ED and ray EF. So right there is ray EF that I have drawn in red. Then in blue, going from E this way is the opposite ray. Together they make a line. There is no overlap. There is no gap between where one starts and one ends. Right?